For decades, darkness arrived on schedule across large parts of Africa. Not because the sun set, but because the power did. Cities slowed, hospitals switched to backup generators, businesses shut their doors early, and millions learned to live around blackouts as if they were unavoidable. Then, quietly, without press conferences or billion-dollar announcements, one inventor changed the pattern. No global energy giant. No multinational corporation. Just one generator, and a question no one could answer. How is this still running? What began as a small experimental unit on the edge of a city soon became something no one could ignore. Streetlights stayed on. Clinics reported uninterrupted power. Entire neighborhoods noticed something strange. The blackout never came. At first, officials assumed it was temporary. A lucky week. A backup system. But days turned into weeks, and weeks into months. The generator didn't stop. It didn't slow down. And, most importantly, it didn't consume fuel the way conventional systems should have. Engineers were called in. They checked the inputs, the outputs, the load. Everything looked wrong, and yet everything worked. The generator was producing stable, consistent electricity at a scale usually reserved for centralized grids. Word spread fast. A city struggling with aging infrastructure started asking questions. How much fuel does it need? How often does it shut down? What happens during peak demand? The answers unsettled everyone. It didn't rely on constant fuel supply. It didn't collapse under load spikes. And it didn't behave like any generator they had studied before. Soon, a second unit was installed. Then a third. Small at first, markets, water pumping stations, communication towers. Each time, the same result. Continuous power. Minimal maintenance. No catastrophic failures. For the first time in years, businesses stopped budgeting for blackout losses. Students studied at night without candles. Hospitals ran equipment without fear of sudden shutdowns. This wasn't just electricity, it was stability. Energy analysts began paying attention. Reports circulated quietly, avoiding headlines. The numbers didn't make sense. If scaled properly, this generator could bypass massive sections of traditional power infrastructure. No sprawling grids. No endless fuel convoys. No dependence on fragile supply chains. And that's when the questions turned serious. Who built this? Why hadn't the technology appeared before? And if it worked here, why wasn't it everywhere? Behind the scenes, the inventor remained almost invisible. No media tour. No dramatic unveilings. Just installations, testing, refinement. While others debated theory, the generator stayed online, powering real cities, under real conditions. Government officials began visiting sites quietly. Not to celebrate, but to verify. Defense analysts, energy consultants, and infrastructure planners all asked the same thing in different ways. Can this scale? Because if it could, the implications were enormous. Entire regions could leapfrog decades of energy development. Cities could grow without waiting for national grid expansion. Energy independence would no longer be a distant goal, it would be operational reality. And then came the moment that changed everything. One city connected the generator not as a backup, but as a primary power source. The switch was thrown. The grid held. Nothing failed. And that's when it became clear. This wasn't an experiment anymore. This was the beginning of a different energy model altogether. Behind closed doors, discussions shifted tone. This generator wasn't just solving outages. It was challenging the very structure of how power had always been produced, sold, and controlled. Because when energy becomes decentralized, power, in every sense of the word, begins to move. As the next phase took shape, the tone around the project shifted from curiosity to urgency. What had once been treated as a local innovation was now being studied as a potential blueprint for an entirely new energy architecture. Engineers weren't just asking whether it worked anymore, they were asking how quickly it could be deployed and who would control it if it was. The inventor expanded the system quietly, not by scaling upward all at once, but outward, installing generators in different environments, under different stresses. Coastal cities with humidity and salt in the air. Inland regions with heat, dust, and unstable demand. Each installation became a test, and each test delivered the same result: uninterrupted power. What stunned observers most was not just reliability, but adaptability. When demand increased, the system compensated. When sections went offline for maintenance, the generator redistributed load without cascading failures. It behaved less like a traditional generator and more like a living system, responsive, balanced, and resilient. Energy economists began to run projections. If cities no longer needed massive centralized plants, transmission losses would shrink. Infrastructure costs would drop. Entire layers of bureaucracy and dependency would become unnecessary. The implications were so disruptive that many reports stopped short of public release. Because disruption invites resistance. Utility companies raised concerns. Regulators asked for documentation. Standards committees requested compliance reviews that normally took years. On the surface, it was procedure. Beneath it, there was tension. A system that could bypass existing energy hierarchies was never going to be adopted without friction. Still, the lights stayed on. Residents didn't care about debates in conference rooms. They cared that refrigerators stayed cold, water pumps kept running, and children could study after sunset. Small businesses expanded their hours. Local economies quietly accelerated. And with every uninterrupted night, public awareness grew. Videos circulated online, time-lapse of city blocks that never went dark. Interviews with shop owners who hadn't heard a generator shut down in months. The question spread beyond Africa's borders. What exactly is powering these cities? The inventor remained deliberately absent from the spotlight. No interviews. No viral announcements. Only carefully worded technical briefings and controlled demonstrations. To those close to the project, it became clear that speed wasn't the priority, stability was. Roll out too fast, and the system could be politicized. Move too slow, and the opportunity could be buried. Meanwhile, international interest intensified. Delegations arrived under the banner of energy partnerships. Research institutions requested collaboration. Some offers came with funding. Others came with conditions. The inventor declined most of them. Instead, development continued locally. Training programs were introduced so cities could operate and maintain the systems themselves. The goal wasn't dependency, it was autonomy. Power that didn't just flow into communities, but stayed under their control. That decision raised eyebrows. Because technology that empowers without ownership transfer doesn't fit neatly into existing models. It doesn't generate leverage. And it doesn't stay quiet forever. Behind closed doors, a harder question began to circulate. If this generator could power cities, what else could it power? Transportation networks, water desalination, industrial zones, data infrastructure. Each possibility expanded. The stakes. What started as a solution to blackouts was now brushing up against the foundations of modern development. And as the inventor began testing larger configurations, systems designed not just to support cities, but to interconnect them, the line between innovation and transformation started to blur. As those larger configurations came online, something subtle but profound began to happen. Cities that had once operated in isolation started synchronizing, not through a fragile national grid, but through clusters of localized power systems that could communicate, balance, and support one another. If one unit faced stress, another compensated. Blackouts didn't spread anymore. They simply didn't happen. Urban planners took notice. This wasn't just energy, it was a new foundation for growth. Construction projects that had stalled for years resumed. Manufacturing hubs appeared in places once considered too unstable for heavy industry. Reliable power changed risk calculations overnight. And then came the data. Independent monitoring showed reductions in operating costs so dramatic that analysts initially assumed errors. Fuel expenses plummeted. Maintenance windows shortened. Downtime became a rare event rather than a daily expectation. The generator wasn't just powering cities, it was compressing timelines, accelerating development in ways traditional infrastructure never could. At the same time, resistance intensified. Questions surfaced about oversight, safety, and long-term implications. Committees requested deeper access. Some demanded full technical disclosure. Others quietly suggested integration into existing systems, moves that would dilute the very decentralization that made the generator so powerful. The inventor anticipated this. Safeguards had already been built into deployment. The systems were modular, locally governed, and deliberately difficult to centralize under a single authority. Control wasn't meant to flow upward. It was designed to stay distributed. That design choice changed the conversation entirely. Because centralized power systems don't just deliver electricity, they concentrate influence. And a technology that removes that concentration doesn't just disrupt markets, it reshapes control itself. As adoption spread, a new pattern emerged. Cities powered by the generator became magnets. Talent returned. Businesses relocated. Young engineers stayed instead of leaving. Energy stability created social stability, and social stability created momentum. Outside Africa, observers began drawing uncomfortable comparisons. Entire regions elsewhere still depended on aging grids, fuel imports, and complex geopolitical supply chains. Meanwhile, these cities were operating with resilience built directly into their foundations. Quietly, pilot projects were proposed beyond the continent. Islands, remote regions, infrastructure-poor zones where conventional power had never made economic sense. Each proposal raised the same underlying question: was this technology meant to scale globally, or was Africa simply the proving ground? The inventors said little, but development continued. New versions were tested with higher loads, longer cycles, and integrated storage. The systems grew smarter, more efficient, more seamless. And as the generators kept running, day after day, night after night, one realization began to settle in among those paying close attention. This wasn't a temporary solution to outages. It wasn't even a disruptive alternative. As that realization spread, the conversation around development began to change tone. Projects that once required years of feasibility studies were suddenly greenlit in months. When energy reliability stopped being a question, planning shifted from if to how fast. Roads, housing, digital infrastructure, everything moved forward with a confidence that had been missing for generations. What surprised observers most was how quietly it all happened. There were no grand announcements declaring an energy revolution. Instead, progress revealed itself in small, undeniable details. Traffic lights that never went dark. Cold storage facilities operating continuously. Data centers humming steadily in places once written off as impossible. And the generator kept doing what it always did, running. Inside technical circles, theories multiplied. Some argued the system redefined efficiency limits. Others suggested it was less about a single breakthrough and more about how multiple principles were combined in a way no one had tried before. But every debate ended the same way. Whatever the explanation, the results were real, measurable, and impossible to ignore. As installations expanded, a new generation of engineers began learning on these systems directly. They weren't being trained to maintain old grids, they were being trained to build something different. A decentralized model where energy flowed where it was needed, when it was needed, without asking permission from distant control centers. That shift carried cultural weight. Communities that had lived with uncertainty began to plan long-term. Schools added evening programs. Hospitals expanded services. Entrepreneurs invested without the fear of sudden shutdowns, wiping out months of work. Power stopped being a daily concern and became a quiet constant in the background of life. International observers noticed another effect, one that didn't show up immediately on balance sheets. Dependence began to fade. Cities powered by the generator weren't negotiating fuel contracts or bracing for price shocks. They weren't vulnerable to single points of failure. Their resilience wasn't theoretical, it was operational. That resilience attracted attention at the highest levels. Strategic analysts began mapping scenarios where energy independence altered geopolitical relationships. Not through confrontation, but through irrelevance. When supply chains lose their leverage, influence has to find new ground. Still, the inventor resisted acceleration beyond what the system could sustain. Expansion followed performance, not pressure. Every deployment fed back into design. Every lesson refined the next build. This wasn't a race, it was a controlled evolution. And as the generators continued to spread, a quiet understanding emerged among those watching closely. The real breakthrough wasn't just the machine itself. It was the philosophy behind it, a belief that energy could be reliable, local, and resilient all at once. And that is where the story truly settles, at the moment when something extraordinary becomes normal. When uninterrupted power is no longer celebrated, but simply expected. When cities stop holding their breath every night, waiting for the lights to flicker. The generator didn't arrive with spectacle. It arrived with consistency. And in doing so, it rewired more than circuits. It rewired expectations. What began as one inventor's solution to a local problem grew into a quiet demonstration of what energy could look like when it serves people first. No endless fuel convoys. No fragile grids stretched beyond their limits. Just power that shows up, stays on, and allows life to move forward. Across Africa, cities once defined by outages began to define themselves by opportunity. Businesses expanded. Education reached further into the evening. Hospitals planned with confidence instead of contingency. Progress stopped waiting for permission. And beyond the continent, the message was impossible to ignore. If energy can be decentralized, resilient, and locally controlled, then development no longer has to follow old paths. It can choose new ones. The inventor never claimed to change the world. He simply kept the lights on.